this video is on the amount substance. It's my second video on this topic, and this time it's on the formulas. So the empirical formula is the smallest whole number ratio of atoms in a compound. The molecular formula is the actual number of atoms of each element in a compound. So you could be asked a few things in an exam, one of which is calculating the molecular formula from the empirical formula. This is quite an easy skill. So for example, a molecule's empirical formula is C4H3O2. The MR is 166. Deduce the molecular formula from this. So, the first thing we do is we calculate the MR of the empirical formula. This is just timesing the MRs of each atom by the number of that atom. So for carbon we have 4, so it's 12 times 4. Hydrogen we have 3, so 3 times 1. Oxygen 2, 16 by 2. Add all these values together and the MR of the empirical formula is 83. Next, we divide the MR of the whole molecule, which was 166, by the MR of the empirical formula, which was 83. And this comes to 2. So whatever we got for 2 then, we multiply the empirical formula by to get the molecular formula. So because we got the 2, we times the C4H3O2 by 2, and we get C8H3O2, which is our molecular formula. Another thing you may be asked to do in an exam is calculate the empirical formula. Again, this is easy. So for example, a carbon is found to have percentage composition of 56.5% potassium, 8.7% carbon, and 34.8% of oxygen by mass. Calculate the empirical formula. So for this, the first step we do is we calculate the moles for each atom. So to do this, obviously remember the formula number of moles equals mass over MR. So for potassium, the mass is the 56.5, the MR is 39.1, use your periodic tables, and the moles for this comes to 1.45. For carbon, we get 0.725 moles, and for oxygen, 2.175. The next step is we divide all of our calculated moles by whichever is smallest. So for potassium, we get a value of 2. For carbon, well, carbon is the smallest, so 0.725 divided by 0.725 gives us 1, and oxygen gives us 3. And the ratio of atoms that we got from part 2 are the ratio of the atoms in the empirical formula. So it's 2 to 1 to 3. So then we can deduce that the empirical formula is K2CO3. There is, however, an exception to this third rule in them steps, and I'll do this by an example. So an oxide of nitrogen is 25.9% mass of nitrogen. Find the empirical formula. That's a horribly worded question, but it has been asked. So the first step we do is the same. We calculate the moles for each atom. So for nitrogen we get 1.85, and just note that just because it doesn't say that the oxygen in the question specifically, it's an oxide of nitrogen, so obviously oxygen is present, so it's 74.1% because 100 take away 25.9, and the moles we get for this is 4.63. Again, the second step is the same. We divide all of our calculated moles by the smallest. So for nitrogen, that is the smallest, so we get 1, and for oxygen we get 2.5. This is where the steps vary. So for the third step now, if we have a number which we cannot clearly round, we multiply to get whole numbers. So in this case, we multiply by 2, because obviously 2.5, if we times that by 2, we'll get 5, which is the first whole number we can get. So that means the ratio for this compound is 2 to 5, because we also have to times the nitrogen by 2, we can't just times the oxygen. So the empirical formula for this is K2O5.